This lesson will be about graphing the other four trig functions. We've looked at how to graph sine and cosine, and now we are going to look at graphing secant, cosecant, tangent, and cotangent. We are still basing things off of this equation that you will see in the green box. You can replace the sine with any trig function you want. There are some different things that happen with tangent and cotangent than happen with the other four graphs, and I'll explain why here in a minute. So this is the parent tangent function, the normal, the graph of the just basic tangent function with no transformations done to it, no numbers added in front or whatever. You can see what's different about tangent is, first of all, there is no high and low point. So when we talk about amplitude, with sine and cosine, amplitude was that distance between your high point and your low point in the midline. With tangent, there is really no amplitude, although we'll still talk about it. When you throw a number in front of here, like 3, what that does is it'll actually straighten that curve out a little bit, so it'll kind of make it look more like this instead. And if you throw a smaller number in there, it'll make that curve be a little bit more S-shaped, so it'll kind of go like this if I throw like 1/2 in front of there. So that's what the amplitude does to tangent. I am not really going to be able to see that when you graph these by hand, so we will talk about amplitude with tangent and cotangent, but we won't really worry about it so much, okay? The other thing that is different with tangent, and it is also true for cotangent, is the period. And remember that a period is the distance between when a graph cycle starts to repeat itself, okay? So, this is one full cycle of a tangent period. It actually starts to repeat itself when you get over here. So this much is a period. And if you think about it, it's pi over 2, or half of a pi from here to here, and it's half of a pi from here to here. When I put the two together, that means I have 1 pi for one full period. So one period is 1 pi, okay? And if you think about that in terms of the unit circle, 1 pi, this is 0, this is pi over 2, and this is pi. So tangent repeats itself in just half of a circle instead of a full circle like it does with tangent or with sine and cosine, okay? So when you graph it by hand then, because it only takes half of a circle, you only need 2 quadrants instead of 4 quadrants. Okay, so that's what's different with tangent and cotangent, and you'll see how that plays out when we actually graph them by hand. The other word you need to be familiar with, and I know you've talked about this word before back in Algebra 2, is the word asymptote. These dotted lines are the word asymptote. You need them in there, so when you make the graph, you need to include those. And those are spots where tangent is undefined, okay? Those are the spots where that trig function, in this case tangent, is undefined. And I'll kind of explain why to you really quick. It is one of the spots it's undefined at is pi over 2. And if you think of the unit circle, pi over 2 is up here, okay? And tangent is your y value over your x value, or your up-down value over your left-right value. Well, your up-down value is 1, and your left-right value there is 0. Since you can't divide by 0, tangent is undefined at that spot. So every place a trig function is undefined, you are going to need an asymptote, or that dotted line that goes up and down on that graph. So that happens with tangent. And you can see that it also will happen with cotangent. Okay, cotangent, the curve goes the other direction and it crosses the x-axis and it has asymptotes in some different spots, but tangent and cotangent are very similar to each other. So that you can, yeah, very similar. Notice for both of them that your domain is all real numbers except for the spots where it's undefined right here. And so anywhere there's an asymptote, your domain will not exist. And then your range can be anything here, okay? All right, then this is a cosecant curve. And cosecant is the reciprocal to sine, and I just kind of want you to notice this. This is a normal sine curve, okay? And you can see that, like, if I flip this, I get that top curve, and then if I flip this, I get the bottom curve. So you can kind of see how sine and cosecant are reciprocals to each other. Same thing here. There are spots where cosecant is undefined, and so you do need asymptotes. And then the other thing I want you to point out, or I want to point out to you, is that it takes both an up curve and a down curve for the cycle to repeat itself. So this is one full period. Okay, that much is one full period. And you can see that the period is still 2 pi. And when you think about the unit circle, 2 pi is one revolution of the unit circle, which means it takes 4 quadrants to make that period repeat itself. Okay? And then secant is very similar to cosecant. It just crosses the x-axis and has different asymptotes at different spots than cosecant, but the same properties apply. All right, so we are going to graph a couple of these by hand so that you kind of get a gist of this, and we'll go from there. Same kind of thing that we talked about the other day. First of all, you need to use your even and odd properties because there's a negative right here. And so because there's a negative right there and cotangent is an odd function, you will take that negative and you will put it out in front. So it will be out here. Okay. That negative out in front does mean that cotangent is flipped. So this is a flipped curve. Okay. The amplitude is 3. And we talked a little bit about that in the beginning, that when you have amplitude for tangent and cotangent, you don't really see it because it doesn't have a high or a low point, but it will straighten out the curve or flatten out the curve if you need to. I'm not really going to be able to see that when you graph these by hand, so we're not going to worry so much about it, but just so you know, that is the amplitude. Then I have this plus 0 back here, so my midline is still 0. All right, then here's what's different. One of the things that's different when you graph tangent and cotangent graphs. Okay, for sine and cosine, we always did 2 pi over the number in front of the x because its period was 2 pi. But for cotangent, you can see its normal period is only 1 pi. So when we figure out the period, we are only going to put 1 pi over that number in front of the x. Okay, that is true for cotangent. It is also true for tangent. Okay, so you're going to do that with those two trig functions. With every single other one, you're going to put 2 pi over the number in front of the x. Okay? All right, and then I'm going to flip that pi over 2. Instead of dividing by pi over 2, I can multiply by 2 over pi. The pi's will cancel, and my period will be 2. So that's one of the things we do different with cotangent. Because there's nothing added on inside the parentheses here, I have no left-right shifts, and I won't have any of those today. We're not going to worry about those today. We'll add that piece in the next lesson, okay? All right, so cotangent. My midline is 0. My amplitude is 3, although it's not going to really matter. But if I go 3 up from 0, I'm at 3. If I go 3 down from 0, I'm at negative 3. And then with cotangent, my period is 2, but remember the normal period for cotangent is pi, and that is only 2 quadrants. And so I only have to make 2 quadrants when I make my graph. So I'm going to make one here, and I'm going to make one here. Okay? Again, the normal period is pi, which is 2 quadrants, so when I divide my graph, I only need to divide it into 2 quadrants. My period was 2. If I cut that in half, I get 1. Then I'm going to follow cotangent's normal curve up here. I'm going to follow the pattern, and I know this is a little small, but you have yours to look at. This much is one full period, so that's all I really need to graph is just that much of it. That's one full period, and that's all I need to mark on my graph. So you can see that you have an asymptote right here at the y-axis, and then at the first hash mark is where your graph will cross, and then you have an asymptote here. Okay? So I'm going to graph those first. So I will have an asymptote, and again, you have to draw your asymptotes in. You can't skip your asymptotes for me. And I have an asymptote here. Okay, and then right here is where it's going to cross. Now, this is a cotangent curve, and so normally cotangent does look like this. However, this graph is flipped, and so instead of it looking like that, it's going to go the other direction and look like this. Okay, because it is flipped, and that's what happens when you flip a cotangent graph. So, that does it. All right, here is a tangent one, and I will do that for you really quick. I have no even or odd properties to worry about because there's nothing right here, so I don't need to worry about that. If I look at what's out in front, there's no negative out in front of that equation, so it is not flipped. My amplitude, the number that's out in front, is 1/2. Again, that doesn't really matter for tangent and cotangent, but we're going to record it anyways. I have a plus 0 back here, so my midline is 0. And then again, this is tangent, and its normal period is pi. So when I do that, when I calculate the period for tangent, I will do pi over the number in front of the x, which is just pi over 2 in this case. Okay, so I'm going to label my graph here. My midline is 0. My amplitude is 1/2. And it doesn't really matter where I put it, because when I graph this by hand, I can't really tell. Again, my period is pi over 2 in this case. And because tangent's normal period is pi, which is only 2 quadrants of the unit circle, I only need to make 2 quadrants when I do this. So I'm going to make 2 quadrants. I'm going to just make mine a little smaller this time. It doesn't really matter. And so my normal, or my period in this case, was pi over 2. So there's that. If I cut pi over 2 in half, that means I'm going to double the bottom number, and I will have pi over 4. And if you follow tangent's pattern up here, I need to see one full period of the tangent graph. And this is one full period of the tangent graph. Okay? So what that means is that it's going to cross at the origin. At the first hash mark to the right, you will have an asymptote. At the first hash mark to the left, you will have an asymptote. And I probably should label that first hash mark to the left then. So if this is positive pi over 4 here, this is negative pi over 4 over here. Okay, and I will have asymptotes here. And I will have an asymptote here. And then it will cross the x-axis at the origin. And this graph is not flipped, so it will look like this for tangent. And that's all I need to see. If you give me more of that, that's great. If you wanted to instead graph this tangent curve right here, that's totally fine. Then what would happen is you would have this one. All I need to see is one full cycle, and I need to have it placed the right spot on the axis. You would have this one, and this would be 1 pi over 4, 2 pi over 4. This would be 3 pi over 4 right here. You would need to label that spot for me. And it would look like an asymptote there, and then you would have this curve. So if you'd rather do that, that is fine too. I just need to see one full cycle. If you give me more than that, bonus. If you don't, that's fine. I just need to see one full cycle somewhere on the graph placed correctly. All right, and then the last one we're going to do here is a secant curve. And we will graph that here real quickly. So let's see. Secant, I'm going to need to use the even and odd properties right here because there's a negative. Secant is an even function, and so that negative right there will be crossed out. And I don't need to worry about it, and so this will be my equation. Okay? So that graph is not flipped. It has an amplitude of 2. Again, I have this plus 0 back here, so it has a midline of 0. And then when I calculate my period, I'm going to kind of pay attention to this. Secant's normal period is 2 pi, so when I calculate my period for my transformation, I will go 2 pi over the number in front of the x, which is 3. Okay? Again, because the normal period is 2 pi, that's one full trip around the circle, which means you need 4 quadrants when you do this. So 1, 2, 3, 4 quadrants when you do this. The period is 2 pi over 3. If I take half of 2 pi over 3, I will get 2 pi over 6, and 2 pi over 6 reduces to 1 pi over 3. If I take half of that, I double the bottom number, I get 1 pi over 6. Or if you wanted to take 1/4 of 2 pi over 3 to get this spot right here, that works for you too. And then I'm going to count. This is 1 pi over 6, 2 pi over 6, 3 pi over 6. I'm going up in increments of 1 pi. And 3 pi over 6 would reduce to pi over 2. If you would rather, to get this spot right here, take 2 pi over 3 times 3/4 and then reduce it, that's totally fine too. Whatever works for you, however it's easiest for you. Okay, my midline is 0. My amplitude is 2, which means I'm going to go 2 up from 0, which is 2, 2 down from 0, which is -2. Okay. With secant, again, I want to see one full cycle, and I don't like to see those curves broken up. So I want you to like give me probably this section. If you want to do the other 2 curves, that's fine. But I want to see 2 full curves, and don't break the curves up for me, please. Okay? So what happens is you're going to, that curve is split on the other side of the y-axis. So I actually need to label this spot over here as -pi/6. Okay? And then I'm going to follow this pattern. So at that first hash mark to the left, I'll have an asymptote. It'll cross the x-axis. At the first hash mark to the right, I'll have an asymptote. And then it'll again, or not cross the x-axis here, but bottom out right here. And then it will top out right here. And then at the next hash mark, I'm going to have an asymptote. So I'm going to just follow that pattern and complete my graph that way. Okay? So at the first hash mark to the left, I have an asymptote. The first hash mark to the right, I have an asymptote. Then it will bottom out right here at 2 in this case, since your amplitude is 2. This graph is not curved or not flipped, so this is an up curve here. So it will look like this. And then it will bottom out here, and just following the pattern at that next hash mark. At the third hash mark again, I will have an asymptote. Please do not eliminate the asymptotes. You have to have them in there for me. And there is one full cycle of this secant graph. Okay? And then I'll just whip out a cosecant one really quickly, just because I want you to see that this one is flipped and what it looks like. So very quickly, I'll take this negative. Cosecant is an odd function, so the negative will come out in front right here. And so your graph will look like, or your equation will look like this. Okay, which means because of the negative now out in front, it is flipped. It does have an amplitude of 1/2, which just kind of tells you where it bottoms and tops out in respect to the midline. I have a +0